Basics of frequency, detailed description. The image explains the basics of frequency, which is one of the most important concepts in electricity, electronics, communication systems, and signal processing. Frequency is the number of times a repeating wave or signal completes one full cycle in 1 second. It is represented by the symbol F and is measured in Hertz. 1 Hertz means that one complete cycle occurs every second. Frequency is used to describe all types of repeating signals, including AC electricity, sound waves, radio waves, television broadcasts, Wi-Fi signals, and mobile communication networks. The image shows that frequency determines how often a waveform repeats, while the period, T, is the time required to complete one full cycle. The left side of the image compares low-frequency and high-frequency waveforms. In the low-frequency waveform, only a few cycles occur over a given period of time, meaning each cycle takes longer to complete. This results in a longer period, T. In contrast, the high-frequency waveform contains many cycles within the same amount of time, so each cycle is completed much more quickly. Therefore, a higher frequency always means a shorter time period, while a lower frequency means a longer time period. The graph also labels the amplitude, which is the maximum height of the waveform, and the cycle, which is one complete repetition of the wave from one point back to the same point. The center section of the image presents the essential mathematical relationship between frequency and period. The first formula is F is equal to 1T, where F is the frequency in Hertz and T is the period in seconds. This formula is used to calculate the frequency when the time period is known. For example, if one complete cycle takes 0.01 seconds, the frequency is calculated as F is equal to 1 divided by 0.01 is equal to 100 Hz. This means the waveform repeats 100 times every second. The second formula is T is equal to 1F, which is used to calculate the time period when the frequency is known. For example, if the frequency is 50 Hz, then the period is T is equal to 1 divided by 50 is equal to 0.02 seconds, meaning one complete cycle takes 20 milliseconds. The image also highlights the important relationship F times T is equal to 1, showing that frequency and period are inversely proportional. As frequency increases, the period decreases, and as frequency decreases, the period increases. The right side of the image explains how frequency is used in Wi-Fi communication. Modern Wi-Fi networks commonly operate at 2.4 GHz and 5.8 GHz, where GHz means 1 billion cycles per second. A 2.4 GHz Wi-Fi signal has a frequency of 2.4 billion cycles per second, giving it a period of approximately 0.417 nanoseconds. This lower frequency allows the signal to travel longer distances and pass through walls more easily, making it suitable for larger homes and wider coverage areas. However, because many devices use the 2.4 GHz band, it is often more crowded and may provide lower data speeds. The image also shows a 5.8 GHz Wi-Fi signal, which has a higher frequency of 5.8 billion cycles per second and a shorter period of approximately 0.172 nanoseconds. Since the signal changes more rapidly, it can carry more data at higher speeds, making it ideal for activities such as high-definition video streaming, online gaming, and large file downloads. However, higher frequency signals cannot travel as far and are more easily blocked by walls and other obstacles. This is why 5.8 GHz Wi-Fi usually provides faster performance over shorter distances, while 2.4 GHz Wi-Fi offers better coverage over longer distances. A practical example of frequency can be seen in the household electrical power supply. In many countries, the electrical supply operates at 50 Hz, which means the AC voltage completes 50 full cycles every second. In some countries, such as the United States, the supply operates at 60 Hz, meaning the waveform completes 60 cycles every second. Electric motors, transformers, fans, and many household appliances are designed to operate correctly at their specified frequency. If a device designed for 50 Hz is connected to a 60 Hz supply, or vice versa, its performance may change because the electrical waveform is repeating at a different rate. Another simple example is a clock pendulum. Imagine a pendulum swinging back and forth. If it swings once every second, its frequency is 1 Hz. If it swings twice every second, its frequency is 2 Hz. If it swings 10 times every second, its frequency becomes 10 Hz. Similarly, an electrical signal repeats continuously, and the number of repetitions every second is called its frequency. A simple way to understand frequency is to compare it to ocean waves. If only a few waves reach the shore every minute, the frequency is low. If many waves reach the shore in the same amount of time, the frequency is high. In electrical and electronic systems, the same principle applies. A low-frequency signal changes slowly, while a high-frequency signal changes very rapidly. In summary, the image explains that frequency is the number of complete cycles a wave or signal makes in 1 second and is measured in Hertz. It also shows that the time period, T, is the time taken to complete one cycle, and both quantities are related by the formulas F is equal to 1/Tt is equal to 1/F and F times T is equal to 1. Low-frequency signals have longer periods and fewer cycles per second, while high-frequency signals have shorter periods and more cycles per second. Practical examples such as 50 Hz household electricity, 2.4 GHz and 5.8 GHz Wi-Fi networks, radio communication, and wireless devices demonstrate the importance of frequency in everyday life. Understanding the concept of frequency is essential for learning electricity, electronics, communication systems, wireless networking, radio transmission, and signal processing.